everyone, welcome back to another YouTube video by SMARTPATHTUTORING. Today's topic is the national grid in GCSE Physics. Starting off with the first slide, I'll be explaining what the national grid is. Electricity is distributed via the national grid. The UK national grid is a giant system of cables and transformers that covers the UK and connects power stations to consumers, anyone who is using electricity. The national grid transfers electrical power from power stations anywhere on the grid, the supply, to anywhere else on the grid where it's needed, the demand, example, homes and industry. Electricity production has to meet demand. Throughout the day, electricity usage, the demand changes. Power stations have to produce enough electricity for everyone to have it when they need it. They can predict when the most electricity will be used though. Demand increases when people get up in the morning, come home from school or work, and when it starts to get cold outside, popular events like a sporting final being shown on TV could also cause a peak in demand. Power stations often run at well below the maximum power output, so there's spare capacity to cope with a higher demand, even if there's an unexpected shutdown of another station. Lots of smaller power stations that can start up quickly are also kept in standby just in case. Going on with the next slide, the national grid uses a high PD and low current. To transmit the huge amount of power needed, you need either a high potential difference or a high current. Example, ASP equals to V times R. The problem with a high current is that you lose loads of energy as the wires heat up, and energy is transferred to the thermal energy store of the surroundings. It's much cheaper to boost the PD up really high, 400,000 volts, and keep the current as low as possible. For a given power, increasing the PD decreases the current, which decreases energy lost by heating the wires and the surroundings. This makes the national grid an efficient way of transferring energy. Potential difference is changed by a transformer. To get the voltage up to 400,000 volts for efficient transmission, we use transformers and big pylons with huge insulators. Transformers all have two coils, a primary coil and a secondary coil, joined with an iron core. Potential difference PD is increased using a step-up transformer. They have more turns on the secondary coil than the primary coil. As the PD is increased by the transformer, the current is decreased. Now there's an image shown here to help you understand it a bit more. Next slide. Potential difference is changed by a transformer. The PD is then reduced again at the local consumer end using a step-down transformer. The current is therefore increased by this transformer. They have more turns on the primary coil than the secondary. The power of a primary coil is given by power, PD times current. Transformers are nearly 100% efficient, so the power in primary coil, power in secondary coil. This means that PD across secondary coil times current in secondary coil equals to PD across primary coil times current in primary coil. Thank you for watching my video, guys. Hope you understood everything. Make sure to like, subscribe. We'll see you in our next video.